And then after the Capstone conference, you'll be able to find the recorded sessions on our website. We've also put the link to our Slack channel in the Zoom group chat right now. So if you'd like to join us over in Slack following the conference, we'll start some different channels there, and you're more than welcome to start your own channels as the discussion merits that. So with that, I am going to introduce Susanna Howe as the facilitator for the session and turn it over to her.
Great, thank you so much, Amy. Can everybody hear me all right? I'm assuming so. Okay, so I love this session, Nifty Ideas and Surprising Flops. We started doing this, wow, many conferences ago, and it's a great opportunity to have rapid sharing and rapid ideas and hear a lot of things in a very short amount of time. And so what I've done is I've recruited ideas in advance, and we have a slate of 12 Nifty floppers who are going to present today. Each one of them has been limited to a single slide. So they will present their single slide, and I'm going to limit them to a 4-minute slot. So if this moves really fast, that's why, but it means you'll get 12 different ideas out of it. And what I would encourage you to do as you're listening, if you have questions, please use the Google Doc that just got shared in the chat. Please use that, and that will allow you to address questions to particular presenters and also add comments. If you can't access that for some reason, you can use the chat itself, but the chat window then pops up for everybody, and it's a little distracting for the presenters as they're presenting. So I would encourage you to use the Google Doc if you can, and then after they've presented, I will turn it over briefly to each presenter to answer a question. And if at the very end, if we have time after all 12 have gone, if we have additional time, then we can take some additional questions. But if you put your question in the Google Doc, we will make sure that the presenter answers the question even after the session. So it may not get answered during today's session, but it can get answered eventually, and you'll be able to get those answers. So this is just to give you a little taste of everything that's happening as we go forward. And so with that, I think we are ready to start with our first presenter. And I will be taking us through the slides. Some of them have animation and some of them don't. But we're going to start off here with virtual, hang on a second. Virtual project presentation session with Bridget Smizer from Northeastern. So Bridget, take it away.
All right, so every fall or spring when we have our Capstone 1, whenever we have that, we tend to present all the projects on the first day so that students can figure out what they want, find other people who are interested, and then rank the projects. Now, usually we do this in the form of a poster session where the advisors produce posters about all their different projects and people walk around and talk to the advisors. This is a little bit difficult when everyone is scattered throughout the country. So for Summer 1 and Summer 2, for our Capstone 1 courses, we did a virtual project presentation session in Microsoft Teams. Now we chose Teams because if you've used Zoom, you know that if you have a bunch of breakout rooms, someone has to actively switch people in between. We have 125 students. That seemed like a big burden. But with Teams, you can set up basically a channel for each projects. And in the general channel, we started a meeting. That was our general meeting. We gave a little overview. And then all students have to do is go to the other channels and join an individual meeting for each advisor. And when they were done with that advisor, they could leave that meeting and join another one. So this way, we didn't need anyone to manage the meeting. Students could switch as needed. And the chat allowed people to find other students who were interested in the same project if they didn't already have a project or a team going in. And each professor was required to produce slides for each of their projects so that they could have a visual to share with the students in their individual channels. And we found that worked very well without needing a lot of organization or setup. So with that, I'll take any questions you have.
All right, so Bridget, we have a question here. Oh, sorry, we had a question, but it went away. Anonymous Blobfish is trying to write you a question, but I don't know what it is.
Okay.
And I don't see that we have any have come in on the chat. either yet. So do you want to give us any, can you tell us briefly, actually, Bridget, as this question's coming in, will this work in Zoom as well as Microsoft Teams?
The only problem with Zoom is that if you set up separate breakout rooms, say one for each advisor, you need a controller of some sort to put people into breakout rooms. And you sort of need to set that up ahead of time. So these are the people who are going to this room, which can be done, but it takes a lot of work. It also, the students have to ask to be put into another breakout room. So this way, the students were able to control everything. When they were done getting the information they felt they needed, they just left. If they wanted to go in and out a couple times, and that way, again, we needed no controller, and the Capstone coordinators, who were also advisors, didn't have to try to manage the whole thing in addition to talking about our projects.
Great, thanks, Bridget. We had a question, did you have any faculty who were considered guests?
Yes, no, it was all these different projects here. Each of those people are a Capstone advisor. You could have guests if you wanted. We did this, actually, we set up a team for the class to do this. And we've also found that students have been setting up their own separate teams for their project and using that to manage communication and documents. So it sort of introduced students the idea, so there was that added benefit as well.
Okay, great. And final quick question, did you consider having faculty give a video in advance?
We didn't do a video because we wanted to not have too much startup. We want to have lots of time for free conversation. So we put all the descriptions of the projects up, but because the projects are designed to be really open-ended and most are not industry sponsored, there wasn't too much to make a video of.
Okay, perfect. Thank you so much. If other people have questions or comments for Bridget, please add them to the Google Doc. Alexis, maybe you could share on the chat one more time where that doc is, and then people can actually say specifically at Bridget, and then she'll know that's a question that she is to answer. And with that, that was our 4-minute slot. Thank you so much, Bridget. We are going to move along to our next Nifty flop in rapid fire succession. And we have use of adjuncts for mentoring with Jim Hartman from UNC Charlotte. So Jim.
Good afternoon, everybody. So the background on this is we're a research university, so research is the #1 priority for our faculty. And sometimes, although faculty generally like to mentor senior design projects, a lot of times they don't have time for it. So we've had some trouble getting faculty agree to mentor projects. When I was at Capstone 2018, I talked with RIT, I believe it was Beth DeBartolo, and she told me that they solved this problem by adding adjunct faculty that were generally retired engineering managers from the local area. So I tried this in the last academic year, and I hired 2 part-time adjuncts to do this. And for the Nifty part of it, it worked. The 2 were engineering managers from industry. They were on industry projects, and they did a very good job with the mentoring and following the grading guidelines in the academic program. The flop part of it is that I didn't realize how hard it is to add adjunct faculty in a university. Some people have raised ABIT concerns of saying that if you have them as adjunct faculty, they now are subject to an ABIT audit. And do you really want to have people who are really outside the university being part of ABIT audits? So I don't really know how to address that. I'm from industry. I worked in industry for 34 years before I came to academia. I'm not real familiar with ABIT concerns, so I wanted to see what people thought about that and if that's a real concern or how that's dealt with. The bureaucracy of hiring was very difficult. And there's a little bit of a concern about should we let outsiders into our program or should we just keep this within the university? So just wanted to hear if anybody else has tried this, what their success has been.
So we've got questions coming in right now. I'll take a moment just to let people know these slides will be available after the conference. So I know I'm sharing a screen right now. You can get access to these in addition to the notes from this session after the conference. So don't feel like you have to scribble notes down furiously right now. So I'm waiting for some additional questions for Jim. I've got one coming in right now. So can you comment how you train or orient your mentors?
Yeah, that's a good point. So I personally did this, since we only had 2. I believe RIT has like 15 now, so I'm not sure how they do it. But with the 2, I did this personally myself in that I gave them, I actually brought them on about halfway through the previous semester so that they could attend design reviews and I could give them training. And we use Canvas for grading. So we trained them on Canvas. When I would do grading, I would bring them in to show them how to do it. So I gave them invited them into some of our events for about a half semester before they started. And then we started them as, real instructors after that training.
And then one other question, Jim, are the mentors also the graders or the evaluators for the team, or are they just supporting the team?
So that's a very good point in that we made them the grader, the mentor, the evaluator, everything. And we do have some industry people who are kind of like volunteer advisors to teams, but they're not the graders. And I didn't want that because what I needed was somebody who would do the entire task of not only mentoring the students, but grading them and holding the students academically accountable to it. So there's some people I interviewed for this who really weren't comfortable doing that. And I didn't want to get to where I had to have somebody else backstop them because that doesn't solve the problem if you still need another person doing the grading behind them.
Great, thank you, Jim. All right, so as we're doing this in rapid format, we've been getting a bunch of questions in. If there are specific questions for Jim that you still want to add, please do, and we can try to get to them at the end. Otherwise, Jim can respond to them after this session. I've heard from a couple people as I'm trying to monitor different chat channels here. If you have a comment that you'd like to make, feel free to make it either directly in the chat or even better, make it in the document, and then it's there and people will have it and we can have it in the notes. So I don't want to take away time from the Nifty Flop presenters by having other people give comments, but I would really want to capture your comments in some way.
Yes, Suzanne, I see some comments coming in about people with the ABET experience. We probably won't have time to get to all that, but if people could contact me with their email address to talk about that, I'd really appreciate it. My email is jim.hartman@uncc.edu, but I would like to find out more about the ABET experience of people that are doing this.
Great, good. Thank you so much, Jim. Appreciate it very much. And now in rapid fire, we're going to move on to the next one, which is John Lenz and Dustin Rand from the University of Vermont talking about longer class sessions and dedicated studio time. All right, so John and Dustin, take it away.
I'm assuming John is online. He was spearheading this.
All right.
Hi, Dustin. Yeah, so we're tag teaming this. I just turned off my off mute. We had the challenge at UVM where we have 2 sets of capstone projects. We have civil and environmental, which I teach, and Dustin teaches mechanical, electrical, biomedical. But overall, we're having the issue of teams not having enough time to meet outside of class. And we had this structured as 3 50-minute class sessions a week. And most of the time we were spending those class sessions on lectures and short discussions, but not much time for teams to work, especially at the beginning and middle parts of the courses. So we together were successful in getting the schedules changed so that we had essentially 3 sessions a week. I had 2 2-hours and then a 1 hour, and Dustin had 3 2-hour sessions where students would always meet. They were always able to meet, and it really made a big difference in the amount of time students could be together, as well as having the opportunity to keep them in class together. So it was visible when they weren't in their team session, sitting at their table. And so attendance went up. We also had the benefit of having these longer sessions available for reviews. So when I had some project review periods, I could use those sessions rather than scheduling something at night. or other times of the day. So Dustin, you have anything you want to add?
Yeah, my class is so big, I could only meet once a week with about a third of the class. So it gave the 2/3 of the class 2 of those 2-hour sessions a week to work as a team. And theoretically, you're guaranteed no conflicts. Although I do know for a fact that when students found out that they didn't have class during that time, some of them scheduled work and things like that. So you can't control everything. But in general, I thought it went pretty well. There was a lot of shuffling that had to be done on the back end to make sure those 2-hour blocks didn't conflict with other classes that seniors would typically take. Once that was done, it worked out actually fairly well, I think. The students really appreciated that extra time, guaranteed time together.
Thank you both. We have a comment that has come in saying that someone else has tried this and it worked very well for them as well. But they've recently put in some online content, reading and videos that students would do in advance of class. And we're wondering if you had tried that to leave more room for discussion during the blocks.
I did not do that last year personally, but this coming year with the pandemic, my intent is to do all my new content online. And then, so that way they wouldn't actually have to physically be in the class to get any new content. And then they'll be able to work remotely as a team or sign up for times in our lab. But I even if we didn't have a pandemic, I would be doing more of that stuff. Put content online so they can learn it and then just quick review and get students working.
And same goes for me. We started the remote in the last 7 weeks of essentially 30 weeks of course. So that at that point, the students were really just wrapping up their projects and there wasn't a lot of outside content to give them.
Great. Yeah, we have another comment here that this is this is a common source of team conflict in Capstone design is when teams can't meet with each other. So you have helped to resolve that with this strategy.
I think that's one of the biggest benefits is in the past we've seen when you're lecturing during those 3 50-minute sessions, students can have time to meet and they couldn't find time outside of that. So this was, I think, a real bonus for the students. I think they really felt, the only downside of that is that then students felt like that was the only time they were supposed to work on their project. So it's a little bit of a double-edged sword.
Good. All right. Well, thank you so much. That was your 4-minute slot, and we're going to continue right along. But feel free if people have comments or questions for John or Dustin to just put them in the Google Doc, and we can address those as we go forward. So, all right, ready for the next? We're moving right along here. Next one, we have the miniature radio flyer fail by Jamie Canino of Trine University. So Jamie, tell us what you got.
Okay, so I had this idea of it basically going through the entire design process in 3 weeks with my students on a very small project where I asked them to redesign the radio flyer wagon that I thought most of them would be familiar with. And one of my main goals was for them to reflect on the process because a lot of times they just get to the end and exhale, right? But I also had some process things I was trying to fix, like so the students didn't see the whole process. Students really don't understand how long a task takes, right? They don't understand how long concept generation takes. They also really don't understand how long it takes to build something, right? When you tell them it might take them a half hour to cut a piece of steel, they don't believe you. And then to try to address communication issues early. And to address the thing, those kids, they've all got on the back of their shirts that they're pointing at, it says, "It'll be fine." So I don't know how many of you have your seniors tell you that. But this was pretty much an epic fail. The students hated it. I didn't like the way it went. 2 mistakes. The first one was that the groups weren't the same as their main project groups. And so the communication issues I was trying to fix didn't really happen. They had different communication problems than what their projects had. But the real problem was just the lack of relevancy. They did not see the connection between the real project, and they really just saw this as a stupid teacher thing hoop to jump through, right? So it really lacked relevancy for them. And so trying to get success from the brink of failure, while this failed, what we did is really look at our curriculum as a whole. So we pushed the design process down to our freshman year so that students could see the whole process. And in our manufacturing process, they also have a design project in there, and that really helps them understand how long it takes for things to make. And so that was more the solution to this problem.
Great, thank you, Jamie. We've got a couple comments coming in, but I'm going to ask you to talk about the relevancy piece. And have you thought about doing a different kind of project that maybe is more relevant to them than a wagon? Is that something that went through your head?
Yeah, really, I don't think that would work because the students are really excited when they see the project list to get started on their project, and they kind of already take ownership of that. And so I'm afraid that even if it was something that maybe they could see a stronger connection to, I think it would still lack relevancy. And then also the more relevant the project is, I think you also run into the harder it is to do in a very short time period. So that's one of the reasons why I tried the radio flyer. I thought I could accomplish something in 3 weeks.
We had another question, Jamie, that came in about the reflection component. Can you talk about how you managed that?
Honestly, I assigned them a paper for them to write and asked them to reflect on, and I had questions like, when did you have communication problems? Why did you have those problems? What part of the process took longer than you expected? Things like that.
Okay. And just for clarification, this was done during the first 3 weeks of your capstone course, not in another course?
Correct, the first 3 weeks of the capstone course.
Okay. All the chats that are coming in. Have you looked at, there have been apparently other studies where people have looked at other kinds of projects that can be done at the first couple weeks. So that's something maybe to think about.
Yeah, some people have had more success than I have.
Okay, great. Good. Well, I just want to point out that the beauty of this session is that we're getting nifty ideas that worked well, and we're also getting surprising flops that didn't work as well. And real kudos to the people who are willing to share the things that didn't work so well, so that the rest of us don't have to do those same kinds of things. So thank you, Jamie, for being willing to share this idea and let us know how your experience was before we all went and tried something like this. So
no problem. It's always fun.
Great. All right, so we are now on to our next one, moving right along. If you have other questions or comments or feedback for Jamie, especially as he goes forward with a new revised plan on his flop, please stick them right in the document. Okay, and the next one we've got going is students or engineers, and this is from Yenlin Han at Seattle University.
Hi everyone, my name is Yenlin Han. I'm a faculty at the Mechanical Engineering Department. I'm also the co-PI for the National Science Foundation sponsored Revolutionizing Engineering Department, RED projects for my department. So the goal of our RED project is to build a culture that foster engineering identities. So we have made many, many changes. And today I'm just going to talk about one of them. So we want to basically change our language that we use in senior design projects. So we don't call students anymore, they are engineers. And me as a project coordinator, I'm not the professor anymore. I'm actually the division manager. And next. So basically, I'm just gonna share with you a few ideas that, in terms of the change of language that we use. For example, lectures are meetings, workshops, students, certainly engineers, and we don't have a syllabus anymore. We have project briefs, and the learning objectives for senior design turns into their professional responsibilities. All the assessments, grades, and everything is their performance evaluations. And essentially, whatever the deadline schedules that we still use the same deadline schedules. And essentially, the students have a good response, especially underrepresented minorities. They basically, through our focus group studies, they showed very positive responses in terms of the engineer identity piece. And the one that shows in red is a direct quote. It says it's actually very cool to be on the first name basis with the faculty. But Susanna, the next one.
Yep.
So, but there are some problems along the way as well. Since they took other classes, not just senior design, well, I shouldn't say classes anymore, right? So they have other responsibilities than senior design. So it will be difficult for students to kind of make the adjustment, especially we're a small department. We have similar faculties as their supervisor and their professor. So there's some adjustments for students and faculty together to make in order to make this professional language use as a scene and as a culture. So that's my experience.
Thank you. We've got a number of questions and comments that have come in. People have seen the one about the use of the word engineer only if you have a PE in some states. But I want to actually ask you about one of these questions that came in. Did you measure the impact of the change in language? And did you survey the students before and after?
Yes, we did. We are still organizing the data, but preliminary data showed the students have better sort of ways in terms of their design abilities, their professional skills, and problem-solving skill as such. We will basically present our data in the coming ASCE meetings in the 2021. So that's a plan. And to respond to the language and about the, I would say the professional engineering exams, we did talk about that. So there were some other thoughts saying instead of using engineers, we actually could use engineers in training. So they were approaches that we can use, but you know, in the sense that in many other companies or other states, they could use engineers in their title, even though they don't have PE. So we did consider that.
Thank you so much, Yenlin. That was great. If people have other questions or comments of students or engineers, please add them to the Google Doc and we can come back to them at the end. And now we're going to move on in our rapid format to the next one. We have a topic of Legos and Connects in Ideation from Suhail Zekri at the University of South Florida.
Thank you, Susanna. So this idea is not program-based necessarily. It's a little bit more focused on the details and skills taught through lectures, discussions, and activities throughout the year. So the when is, this is done during the initial concept selection of the design process. And I found that working, this is my second year teaching. By the way, I teach Capstone for biomedical engineers to be. And one of the things that I see with the students when they start the process, they come in with so much experience in solving a closed loop or closed-ended type problems, but the open-ended project-based problems, they have a very hard time, and more specifically, they have a very hard time with divergent thinking. So when they're ideating, there is that process of divergence. They want to select, and then move on. So I try to find ways to, and this is an example that I tried last year, and it worked somewhat. So the activity is basically every group is given an initial piece to start with, and that's either a Lego or a Connects, and then they're given a chance to each one build on top of what they're given. So each one will add a piece and move to the next student without being allowed to speak to each other about the idea or what they're trying to build. And then they have to come to a general consensus at the end to stop and then present, basically give a name and a short description of what they built. And the idea here is basically to kind of get into their brains and try to look for divergence and convergence at the same time. So going between divergence and convergence, every time that piece that is passed on. They're seeing and trying to figure out what the other student was doing, and that hopefully generates a lot of different ideas, and then selection of what they want to add to the piece, and then move on to the next person. I found that it worked out somewhat. The students were somewhat interested. However, I think that in the future, what I want to do is I want to add more activities like this that through some play, quote unquote, they would be able to, they would get challenged to think divergently throughout at least the lecture time outside of their meeting time. So I try to, you know, get a chance or give them a chance to develop their skills through these activities.
Great, thank you so much. We've got a number of different comments coming in. One quick question, do you have an earlier class, say sophomore year or something like that, where students could practice these activities as well?
So that's a very good point. Our students in the curriculum, they actually have a Foundations of Engineering course that is design based, and that's unfortunately, fortunately and unfortunately. So fortunately, it starts early, so it's the first class they take, it's their first semester, but then we don't have anything in between that is design based. So that's the point where we are at the curriculum.
Mm-hmm. And I have a quick question, a follow-up on this. So given that the focus of this conference in part is teaching Capstone in the era of COVID, do you have suggestions of how you might do this in a remote setting?
That's a very good question. Actually, in the previous session, one of my questions, and I didn't have an answer. There were so many questions about how to do all of this during COVID time. So my colleague who teaches lab decided to, the two labs, decided to actually record all of the labs as she makes them. So what I plan to do is to continue to provide this experience as a demonstration. Now, one of the things that I'll be doing this semester, hopefully this coming semester, I applied for a hybrid setup. So I am allowed to meet with as many as a maximum of 8 students at a time. So what I plan to do is I plan to do the asynchronous stuff, the demonstrations, the lectures recorded, and then bring in a group at a time and meet with them at like a 15-20 minute long session. And that's where I hope to do these things, plus follow up on their progress and such.
Perfect. Great. Thank you so much. Really appreciate it. All right, moving on to the next one. We now have the importance of documentation from Gaurav Shakhar from the University of Texas at Dallas, which is where we would have been in June, and hopefully we will be there again next summer. So take it away.
Well, thank you so much. Can you move to the next part? All right, so we started a consulting class where, in fall of 19, where students are taught some consulting concepts when it comes to technology consulting or management consulting, and then they also work on a project, as any Capstone class would have. One of the things that came out at the end was, or towards in the middle of this class as well, was management of expectations of the project sponsors. And we saw a variety of things happening across. Some of the sponsors were kind of happy with the way things were going on. Some of them felt there could have been more in terms of making sure that they were aware of the deliverables that the students were doing at the end. So what we did was we included that in the first 3 weeks, the students are supposed to submit a project charter. In that project charter, they have all the requirements and who's working on what and what's the responsibilities, roles, and everything documented so that there is a sign off on that from the sponsor that this is what they're delivering at the end of the semester. And we use that document as a project plan and to make sure that the expectations are managed. When the first version of that document came out, I could see, again, there were a lot of holes in it because students would vaguely capture what they're trying to deliver and could see that this would again run into the same problems. So came up with an activity where students were given 6 sheets of paper, and they were given a few pieces of tape, not longer than 6 inches. And they were told that if they want more sheets of paper, each sheet of paper is $10,000. Each inch of tape is, say, $5,000. And what they have to do is they have to make a bridge out of these sheets of paper. And this bridge should be such that if I have a 1 liter water bottle, it can pass beneath the bridge. And if I put this bottle filled with water on top of the bridge, it can withstand the weight for at least 20 seconds. And they were supposed to first ideate as to how they're going to create this thing. And they were supposed to take notes and document the whole process. And everybody came up with their ideas in, say, about 20 minutes. After 20 minutes, I asked them to swap their plans. So whatever they had written, they have to give it to another group and use that group's plan to create this bridge. The problem was a lot of them did not take notes, first of all. They had it all in their head. They knew how they were doing it and they did not document it. And they were forced to use the documentation that was out there. And in most of the cases, again, if some group was lucky to get some good documentation, they were able to make a great bridge. But in most of the cases, they did not. And that was just to reinforce the idea that, you know, you need details written out in black and white so that somebody can read it and attest to it that, you know, they are all in sync with the idea of what you're trying to deliver. The students were given another week to revise their project charters, and there was a lot of difference, you know, huge amount of detail in the charter itself. And that helped towards the end, because now the feedback at the end of the semester that we got from the sponsors, most of them said that that project charter document really helped keeping them and the students on track.
Great, thank you so much. We've had a lot of comments coming in saying people really like this activity, especially the documentation piece, that's what ties it together and reinforces the importance of it. Quick follow-up, same one I asked previously, how would you see this working in an entirely remote setting? Would you have students do the project individually and then share documentation?
So again, it will be again in a group. You know, there are some online simulation platforms to do activities. The idea is you can have any activity online. What you need to do first is, are you documenting it? So that's the piece that we want to reinforce. And I mean, it can be delivered in any setting. Definitely in person is better, but with the restrictions, it can still be done in the same sense, in the same way.
Wonderful. Great. Thank you so much. Really appreciate it. We're going to move right along, but if you've got other comments for Gaurav, please put them in the document and he can come back to them later. All right. Next up, we have Motivating Test Design with Lawnmowers from Josh Gargak at Mount Union.
Hello. So the motivation of this was to try to motivate the students to think before doing performance tests. So at Mount Union, we have a 2-semester design. The first semester focuses on coming up with the design, evaluating it. They order their parts before they leave for holiday break, and then they get back in January and they start building. So this would take place in the second semester. So I tried to introduce this idea of performance tests, and of course, ABET Outcome 6 has students performing tests. So what we do, we're a rural Ohio school, so almost everyone is familiar with a lawnmower, has used one before. And this is a mechanical engineering class. So I say, we're designing a new lawnmower. What are our design requirements? And they shoot out a bunch. Common ones end up being mow without clogging, be less loud or quieter, and be able to mow hills, you know, common issues that people have with their lawnmowers. And then I break them into groups. Each group takes one of the design requirements and comes up with a experiment plan of how they're going to prove that this hypothetical lawnmower that we made is satisfying these the original design requirement. So they come up with the plan with diagrams, and then they'll actually go up and put them on the board, and we'll have a discussion. So in part 2, I can go around and talk to each of the groups as they're working. And in part 3, when we talk as a class, we can start to see some of the flaws that they have. They often don't think very well about a well-controlled experiment or test. So for instance, groups that are trying, that their design requirement is that the lawnmower has clogs less. For one, that's not a well-defined design requirement to begin with, because it's hard to prove or to quantify if you've met it or not. But we talk about, okay, so they said, okay, we're gonna go out and mow and we're gonna see if it clogs, and if it doesn't clog, then we're good. It's like, well, okay, well, what's the it doesn't clog after a certain amount of time or a certain acreage of mowing. And then, so then they start thinking about that. And then they said, okay, so we're going to mow 2 acres, and if it doesn't clog, we're good. And we're like, so then, okay, how tall is the grass? Is it 2 inches tall? Is it 3 inches tall? Is it 4 inches tall? So then they have to think about that. And then I say, okay, well, my lawnmower usually clogs if I'm mowing wet grass, right? So that really gets them thinking of controlling the experiment. And we talk a lot about the possibility of somebody else performing these tests, right? So the last presenter talked about documentation. So here we try to reinforce the idea of, if you are giving your test plan to the least competent person you know, they should be able to follow what you've designed and perform the test. So it ends up being a lot of fun. It's really active. It's just one lecture. And this past year, I had a student that actually interned at a place that designs lawnmowers. So some of the plans that the student groups came up with, he could actually verify that that was, in fact, what they did. So it's good practice, because a lot of times they have to think about the equipment we actually have and how they would actually be creative to make low-cost testing rigs, because with their capstone projects, most of the cost is going into actually making the thing rather than buying equipment to, perform these tests.
Great, thank you, Joshua. One quick question that has come in. Do you teach the design of experiments elsewhere in the curriculum, or does that come as part of this?
So they do they don't have a specific experimental class. They do have a lot of labs, but this is really one of the first times in which they're actually going to design their own experiment. That's not something like finite element analysis or like programming based.
Great, good, thank you. All right, so feel free to add other questions or comments for Joshua over in the Google Doc, but we are going to continue our journey moving right along through some more nifty flops. And next up, we have protecting people, proper protocol or painful process. Or does that say process? Yes, okay. All right, so Chris Yeager-Helton from Northeastern. And Chris, whenever you're ready, let's give her a go.
Thanks, Susanna. So in Capstone, we typically need to test our ideas and designs to see if they've been effective. And often this involves end users, surveys, interviews, focus groups, observation, subjects providing input, data from people that includes demographics or behavioral profiles. So in many of these cases, we need to follow policies for the protection of human subjects in research. And at Northeastern University, we've introduced this concept in Capstone in partnership with the University Institutional Review Board, or the IRB. This has been extremely valuable, well, mostly. We know we need to teach our students about the protection of human subjects in research if they're testing with human subjects, for all the right reasons, as well to address some ethical issues with ABET. So we told students how good it is to do so: respect for persons, beneficence, justice. We asked them to go explore the university IRB site and fill out an application for research related to their capstone project. And this was in Capstone 1 after they had their projects. Well, those 8 to 10 pages didn't work out so well. They didn't really have clarity as to why it was important, and they kind of just did it to get it done. As was said earlier, a hoop to jump through, as Jamie said. So right idea, but a bit of a flop. So then next time around, we also presented a series of actual case studies showing what can happen if you overlook the protection of human subjects in research. Examples are the shocking Milgram study, stressful observation of workers on the job, testing a peanut shelling device without considering peanut allergies, the effect of an inversion table on cardiac patients, a self-operated Hoyer lift that needs to be tested considering the safety of the mobility impaired operator, and HIPAA issues when looking at appointment compliance and waiting time in a lower income community health clinic. Well, protecting human subjects and the bad things that can happen, this resonated more with the students, considering what can go wrong if this aspect is not considered. This is progress, but not full Nifty mode. Finally, we brought it closer home by adding some real world case studies for the students to review and consider for themselves, whether they should involve the IRB or not. And even if they don't get to make the final decision, they're now considering all the implications. So we had the original case studies, and then this time we also presented 6 case studies and involve the students. And here's some select examples. So case 1 was a blood serum apparatus. And case 3 was IndyCar pit crew procedures, and there were specific questions around each of these. Case 5 was interface for workout device at a local gym. So we talked to the students about that, and then we wrote up and adjusted an assignment. And we had the students envision the research or testing protocol that involved people, and they only needed to complete a carefully selected portion of the IRB application. And whether their testing protocol was real or hypothetical, it would be ideal if it related prospectively to their capstone project. So this was most effective, showing the actual effects of neglecting the aspects of testing, presenting real cases of what can go wrong, involving students in considerations of actual cases as well, and then streamlining the assignment to the essentials. So now this is more of a Nifty idea.
Great. All right, Chris, thank you so much. Excellent comments. Let's see what we got for questions on this one. Sorry, I was busy doing all your animations there. All right, so a question was, how long does the process take for the IRB to get it completed? Some people have found that it takes longer than the class time to be able to get IRB approval.
Oh, they don't need to get the IRB approval. We actually have them fill out the application and we review it because I work very closely with the IRB. And so they don't have to actually conduct this test. They're envisioning a research project to test it. And then when the time comes to actually do it, then they're much more familiar with the questions and the mindset. So this is a real or hypothetical study, but it's not ready to go yet.
Excellent. Great. All right. I think, unfortunately, Chris, we are out of time with that, but people who have got questions for Chris, please put them in the Google Doc or questions about the IRB approach that she's using here. And then sort of on a related topic, and if you've been noticing, we've sort of been following loosely the pathway of going through a capstone design experience. Next up, we have topic on student organized 510K review panels. And this is Stephen Hugo Arce from FAMU FSU.
Yeah, so I had the challenge of explaining FDA regulations to a class of biomedical engineers without everybody falling asleep. It's usually kind of a boring topic for them if you're just going through PowerPoint slides, or sometimes I'll visit the actual site, fda.gov, and you probably have a similar experience if you're trying to teach ISO standards or something like that. It's not immediately apparent to them when they're first learning about regulations and standards, the power of them and why they need to learn that. And so my idea, and actually I co-taught my first class of BME seniors last year with one of my other colleagues. And we kind of worked on this together, but we had them do a normal report where they presented kind of a mock submission to the FDA. And we graded that, but then we thought it would be a fun idea to have them be the FDA and then form kind of a review panel made up of other teams to review each team's process. And we didn't really know how it was going to work out and how much engagement we were going to get. But it turned out that students are really keen on being critical of other people's work. And actually, it was very positive overall. There was very little negative, nitpicky criticism. But we had students that found we had 3 different types of teams. One was more like a chemistry team. Another one was a more mechanical device. And the third one was more of an electrical engineering type of project, all BME related. And even with the diversity of projects, students from other teams would come in with very specific guidelines or standards or recommendation documents from the FDA and guidance documents. And they actually brought in things that 2 faculty couldn't even have had the time or bandwidth to go and hunt down for the team or direct them to find it. And so the teams ended up being a resource for each project, and it really jump-started this was in the fall semester, so maybe the October, November timeframe. it gave them momentum to carry on into the winter months. And because they had kind of a better idea of what was expected of them in the long run in terms of safety and efficacy, that carried through to the spring, which sometimes, there's kind of a big gap between December and January. So overall, it was a big hit. The students really liked it. I'm not sure what the feasibility would be if you had a very large program, but because we only had 3 teams in a smaller program, it worked out really well. And we plan to do it. This is something that we can do via Zoom. So this is something that we're going to do in the fall. And it's a perfect, COVID pandemic strategy to have them Zoom in and critique each other's projects.
Great. Thank you so much, Stephen. We've got a question that's come in. How easily is this transferable to other types of regulations? And could you talk about that?
So you can see, I put the rubric for how to make a decision. The FDA does a really good job of having kind of clear directions of how to make their decisions. So they had to go through that checklist of whether something is legally marketed, has an intended use. So there's some guidelines that needed to be met. And so if there's any similar specific list of guidelines or standards that need to be met, so let's say that you were making a screw, right? You're a mechanical engineer and you're using SolidWorks for the first time. You could have them assess that versus some standard for a certain type of screw, and say the screw was being used for who knows what, it needed to withstand X amount of force, right? So you could find some parallels there, I imagine.
Great. Perfect. Thank you very much for the response. If there are other questions or comments for Stephen, just stick them in the Google Doc. And we are going to move on because we have just less than 10 minutes and we've got 2 to go. So we are right on track. We're going to nifty flop 2 more things here. The first one up is virtual poster session coming at us as a flop by Rachel Brown from Seattle University.
Hi, I'm Rachel Brown with Seattle University. I'm responsible for finding projects for all of our engineering, computer science, and environmental science students. And I am also responsible for coordinating our end of year event, which is called Projects Day. We have 3 hours of student sessions where they have 20 minutes to present their projects and take Q&A. And then it's usually followed by an in-person poster session where all of our 400 to 600 attendees walk around and talk to the students, and the students get to present their project in kind of a 90-second format. Because of COVID, we weren't able to do that. And so we tried to create that synergy between guests and the students by having each student team host their own Zoom room where attendees could come and pop in and talk to the students. And it didn't really work out very well. There were student teams that sat in their Zoom rooms for an hour and literally just talked to their team members. And some of the teams did have people come in and have conversations. So, hopefully next year we'll be able to do it in person, but we are looking at possibly having to do it virtually again. And I think that probably what we would do is have departmental facilitated Zoom rooms and have a coordinator that could break out sessions so that if attendees wanted to talk to the students, we could put them in a breakout room and they could have those individual conversations. But that way you have a whole room with all of the students from each department able to have conversations with people that come in. I did see one of the questions has come in asking about who the attendees are. These are people from industry. They are sponsors of the projects. It's faculty, students, family, and then also just people from the community. It's open to the general public. And so it is a pretty wide audience. The interesting thing is usually we have about 400 to 600 people attend, but for the student presentations that we did through Zoom, we actually had over 1,100 attendees. So it increased our outreach to the community, people that normally aren't able to come by a significant amount. So in some ways, the virtual Projects Day was a big success, but the simulated kind of poster session was a big flop, unfortunately.
Rachel, I had a question about, did you do a competition poster judging? And were you able to do that in this format or not?
So typically we don't do that, and actually because we weren't trying to necessarily simulate the poster session, the students actually didn't do posters this time. We asked them to have some additional slides that they could share in the Zoom room, but the posters, we found that the format that we usually use a 3-foot by 4-foot trifold poster. That format just didn't transfer to the virtual platform because some people are doing watching the sessions on their phones. Some people have big screens, some people don't. And so trying to get the information that you want that would typically be on a poster just wasn't really possible. So short answer, we don't usually do a poster competition. Individual departments may do that, but as the project center overall, we don't do that. And so as far as I know, I don't think that we did that for the online version either, especially since there weren't posters involved.
All right, in our last couple seconds here, have you thought about doing short videos instead of posters?
We actually did have them do videos. So because the format was very different, you couldn't just kind of walk around and organically figure out where you wanted to go. We had the students do a 1-minute video, and we sent out links to those videos about 3 days ahead of Project Day, so that our attendees that were registered could go through and watch the videos and figure out which sessions they wanted to go see. So we had videos, student presentations, and then we had a kind of virtual poster session where the students could provide more information.
Excellent, great, thank you. So I know this topic of how to present students' work, especially at the end of a capstone, is a very popular one. We have one more Nifty flop that is a Nifty approach to it. So I hope people will join in on this next one. But also know that this topic of how to do expos and presentations is something that we could take up both on the Slack channel and also in future sessions going forward with the capstone design community. So stay tuned for more details here, but let's first take it away to Courtney Pfluger from Northeastern, who's going to talk about a Twitter poster session. So a completely different approach here. Courtney.
Oh, you can't hear me. Hi, I'm Courtney Pfluger from Northeastern University, and I've been teaching capstone now for 2 years in the chemical engineering department. And so listening to Rachel, and what I did is I brainstormed many of the issues that she felt that they had. And I was trying to think of a way that the students could still both the students and faculty could scroll through and see posters. The switch to online, the students had already started working on their posters. So to completely scrap that into another version or do something else was, I felt a little counterproductive. So what we did is I did a poster session. So we have 23 design teams, and this is for their detailed design. So this isn't actually for the full design. We ended up doing videos and Zooms for their final design. And this was for them to show their P&ID, give them the data on what they've done for their projects. And what I thought was good about this is that the students they had all the students there, but you could also invite faculty, alumni, and I even invited the greater engineering community. I invited people from AICHE and ASEE and other universities to also comment, and they did. And so the students posted their posters, and so that was the one there on the right. And actually the students had a lot of fun with it. So as you can see, they made memes of the posters, looking forward to how fun they're gonna have. Some of them did some memes about their company saying, oh, we can't wait for them to work. And so they were able to tweet and discuss and answer questions about their posters right in time. So I gave them 24 hours. They had to comment and discuss. And then I gave the students and the faculty a way for them to also do evaluations doing the Google form. So the students also were required to comment on only a few other posters. And I rotated that so they didn't have to come out in all 23 in the Google form, but that they were required to comment on certain other groups' posters just to make sure that everyone were commenting. And so we got a lot of engagement, and I think this actually worked out really well.
Great. Courtney, thank you so much. We have a question coming in for people who are unfamiliar with Twitter. How much of a learning curve is it to do this?
So actually, I lucked out and I did some research on this, and the Royal Chemistry Society actually had a bit of a tutorial on how to do this. So I actually sent out the students, when they went about doing this, I actually sent out a whole tutorial on what was expected of them, how to post something on Twitter, how to download Twitter, how to like making it. So I actually gave them like a 2-page document that kind of gave them the rundown of how to go about using Twitter and doing this beforehand.
Great. That's excellent, Courtney. Maybe that's something you can share in the Google Doc so people can, or link to it so people can access it later.
Sure.
Good. Okay. Well, I see that we are at our hour. We have used every second of our time. But there is as we've talked about before, there is a Slack channel that we've started up to continue the conversation. In fact, I'm on it, and I was just invited to a new Slack channel on showcase presentations. So there's room for activity and more discussion going forward. We are going to leave this room open for the next 15 minutes. So if you have additional questions or comments that you want to post in the Google Doc and or talk to people through this chat, you can feel free to do so. But I will remind you that in actually 13 minutes from now, there will be a session on scoping projects, and that's on a different Zoom channel. So I hope you will take a quick stretch break, grab a little food, and then come join us for that one as well. And thank you so much, and a big round of applause to all of our Nifty floppers who are sharing their ideas, both good and bad. So thank you all.